So we're here today to talk about open source GPU drivers. This is a BoF, so we want it to be interactive. We have some status to go over of basically most of the integrated GPUs. Don't have anything on discrete GPUs. I know some people have plugged them in, and if you have working PCI, they say it works. I think there's also probably some issues around them. There's a DRM cache flushing function that's not implemented on ARM that I haven't investigated, but I would guess that that may be needed. Seems important. So if anyone does know more about the status of discrete cards, feel free to share your experience. Other thing is there's a couple of demos tomorrow on Panfrost at Demo Friday, so go look at that. And with that, I'm going to hand it over to Tomeu to talk about the status on the different GPUs.
So there's quite some stuff, so we'll try to go quickly. There will be a lot of stuff because we have a lot of drivers now, but I will go quickly over it, and we can have more time for talking. First, at which state they are. FreeDreno, it's quite stable. We have used it in several products, and it has quite good support for hardware and for OpenGL APIs. The VC4, it's more basic hardware support, so it only goes to OpenGL 2.0. Oh yeah, by the way, that content I haven't come up with it. I have asked the maintainers, the developers of the drivers, but any errors there might be are mine, not them. V3D, the hardware is more advanced. Accordingly, the API support is also more advanced. And Naviv supports a lot of different versions of the hardware. API versions are not that advanced compared with the others. The focus has been more on stability and performance, and because it also has been put in several products, and it has been tested in complex scenarios, such as browsers with accelerated composition, WebGL, etc. Now, Lima. This is being merged as we speak. I think the kernel driver has been merged in a maintainer tree and is making its way towards Torvalds, and Mesa as well. As soon as the kernel is merged, I think Mesa will also have that driver in there, and it works with several demos and compositors, but it's quite preliminary, similar to Panfrost, which, well, it's more advanced hardware because Panfrost targets Midgard and eventually Bifrost. And some differences worth mentioning would be probably that we have IGT tests, we test just above the kernel without needing the user space, Mesa, so the tests can be more targeted. We have been testing with 3 different Midgard GPUs and 3 different SoCs so far. It probably works on more. And Alisa, the developer of the user space, has started working on the KP.com appliance, which is a quite advanced thing, I think. Now, what's the next feature for the different drivers? For FreeDreno, geometry and the acceleration shaders, which are needed for advanced OpenGL versions, and other features in 3.2 and 3.3 for the big OpenGL. There's a Vulkan driver already merged, which is very, very basic, so we can expect work there. And then more in the further future, there will be compiler improvements for OpenCL and other kind of stuff, which is also oriented towards OpenCL. We'll be talking more about that later. For the Video Core 4, so more appliance work, having it switched by default, so more people use it instead of the blob that is currently being used in Raspberry Pi. And there's plans to switch into more common code, which is in the kernel. There's a job scheduler, which Panfrost is using, and other drivers, and Broadcom is not yet using it, but there's plans for that, and OpenCL compute in general. Now for V3D, for the Video Core 5 and 6, I think, there's work on more advanced APIs, and there's also some performance work there for media decode. And there are plans already about Vulkan and eventually also performance counters for profiling, etc. Regarding Naviv, they are already starting work on isolating applications so they cannot access memory from other processes. And they are also working on the latest GPU. And eventually they want to reward their compiler, so they use the near intermediate representation, which will unlock a lot of code which is in Mesa and can help them optimize better everything, and that will also help them to support OpenCL. We'll also talk about that a bit later. Regarding Lima, I've been told that there's ongoing work on the compiler. They are testing other scenarios in X11 and Wayland so that there can be zero-copy composition of GL clients, and there's works towards compliance as well, and there's plans towards getting Android working on it. Regarding Panfrost, we are still only immersed in Mesa, but the kernel driver is in its third iteration, and we expect it to have merged for the next stable. And we still need to get a GNOME shell working, and then browsers, which means accelerated composition, because browsers these days are several processes and they exchange buffers, and we want them to composite in the browser and then send that to the compositor for composition. And WebGL, it's also interested in its own. There's robustness and security issues there. We have quite a lot of work on the MMU, performance, security, and the stability as well. We have some issues there. And continuous integration. We already have tests which we are running locally, but there's plans to have those in kernel CI and also in Mesa's CI, so we can test just the kernel or everything. And then once we have all that, then it won't be that hard to reuse the work that is going in Mesa in general on OpenCL, use it as well for Panfrost. There's people working on adding Bifrost support. Everybody wants to do Vulkan. Nobody has started, I know, but and compliance again. Now regarding OpenCL, the status right now in Mesa is not that nice, but there's a good plan in place, and there's a lot of people working on that. Red Hat is putting a lot of time in there, and several drivers already have compute support via OpenGL and Vulkan, and the idea is to have proper OpenCL, and we have a plan to use the CLC compiler in Clang that can give us LLVMIR. Then there's a tool that can translate that from, it's a Chronos tool, translates that into SPIRV, which is also is already supported in Mesa for Vulkan. This is a more expanded SPIRV, and we have also some code to convert that to NIR, and the Gallium drivers are already able to consume NIR. They need to be extended for the compute-specific stuff, but that's not that much work, and that's basically the work which is needed. Something in Clover to implement the first part of the translation, then in NIR we have to extend it so you can accept everything which OpenCL has, and then the Gallium drivers already have to improve their compilers when they translate NIR to whatever the GPU uses to extend it accordingly. That's happening already. There's patches in several branches. 2 series which prepare for that has been merged already, and other work is in review. And more in the future, we need to look at supporting shared virtual memory. which means that you can have pointers, you can have complex data structures in shaders, in kernels. And that will get us quite close to OpenCL 2.0, and there's more afterwards. And there's that idea that once we have all these, we can probably support better machine learning backends by exposing that directly without going through OpenCL. That's more experimental. Now, all of that probably wouldn't be possible if everybody was working alone. There's a lot of code which is being shared and not just code. In the kernel, for example, we have that job scheduler. There's nothing hardware specific there, and that was donated by AMD, who took that code from their own kernel driver and put it somewhere so others can use it. Etnaviv uses it, Panfrost uses it, I guess Lima also, I haven't checked. We have a lot of memory management helpers in DRM itself, which also leverages memory stuff elsewhere in the kernel, so the DRM drivers don't have to invent all that again. There's a series of IOPs which are common to the drivers, and that allows user space, for example, Mesa, to find the right driver for the right hardware and find out which is the display driver, so we can actually show that in the screen. All that is common. We don't have to do it in every driver. And we are, for example, using in Panfrost library code, which is elsewhere in the kernel, because the page tables in the IOMMO in Mali is almost what is used for the CPU. And there's, of course, outside DRM, there's a lot of code which benefit kernel drivers. And if you are mainline, it's easier to use all that new stuff, like defrag helpers that is appearing in mainline, because you don't have to support all their versions. If you have an out of 3 kernel driver, you normally can only use the lowest denominator. In user space, we also have probably more even code which is common and helps. You have the state trackers in Mesa, which is what the applications interact directly with, and there's a very, very big chunk of code there which drivers don't care about anymore. It not just implements state tracking, but also you have emulation of fixed function hardware. Normally, modern hardware don't have that, but there's a lot of games there which are quite old and use that. So that's also for free. Then you can also emulate drawing primitives. For example, Midgard only supports points, vertices, and triangles, but there's some other hardware which also use other primitives, and that's for free given by the Mesa Common Code. You have the compilers for GLSCL and CLC that can produce TGSI, which is the older intermediate representation, or recently near. And then you have a lot of tools around the near and optimization passes that you can that all the drivers can use and don't have to come up with their own. You have that SPIRV to near translator that is important for OpenCL. That's also common. And you have a lot of people there who have already done what you have done for other hardware and can tell you, can share their experiences and save you a lot of time and grief and make the end product much better. And there's as well some profile and tracing infrastructure and tools because, well, we have seen that several drivers have been working on performance counters, and it's good to have a common way of consuming that information so the users and developers can use it. And that's it. So we have plenty of time for questions.
Who wants to be first?
So on a couple of your slides, I saw CTS. Is that the Android CTS?
Kronos.
Okay.
Kronos.
That was it.
You mentioned that on the VC4 slide that there was an intention to move Raspberry into default to using the VC4 driver. In our experience, we've been seeing a lot of out-of-memory situations that I believe Eric Anhalt is aware of that appear to be unsolved. I wonder, is that possibly related to the cache clearing issue that Rob mentioned? Or unrelated?
Probably unrelated, would be my guess. But maybe it needs a shrinker to kind of help free up memory. And the other problem with VC4 is it's CMA based, I think, and probably is not a solvable problem. But V3D has a MMU, so that helps. But I think that is just in set-top box chips. That's my understanding. I'm not really sure. The V3D GPU.
Probably the next Raspberry Pi.
A likely guess.
Without knowing anything about it.
No comments.
Do you know of anyone that's doing benchmarking of the blobs versus the open source drivers?
We haven't gotten there yet, as far as I know.
Robert Frost has been doing that.
Mike.
Robert Frost from Collabora has done some, but I don't have that data here. But I think there's some blog post planned to show that. But of course, benchmarks have to be taken with a grain of salt. More important, I think, is if the customers are happy with the performance once they are building their products.
So for Linux, what's the story about OpenGL and OpenGL ES? Asking because usually distros have to make the choice which one they want to support.
I think that's just which library you link to. There's a libgl.so and libgl.es-v2.so.
Right. So, for example, for Debian, maintainers don't want to maintain both. And if you build, for example, Qt with OpenGL and OpenGL ES support, you have a library explosion because you have to build every dependent library for OpenGL and OpenGL ES. So then that's something which apparently people want to avoid.
Yeah, so Mesa installs both, but I guess some applications, depending on how they make use of that and link to it, there's some libraries which allow you to switch at runtime, even. So, but the question is if libqt is using that or not, probably.
Wouldn't the distros have decided what they're using? Like, it's GNOME shell is built for one or the other, and we're going to support whatever distros support.
So, at least in Debian's point of view, we would like to use the same libraries we use on x86 as we do on ARM. So we would like to have everything link against libopenGL or everything link against libopenGL ES on both platforms. But some proprietary drivers, they typically provide only either one of them. If it's a mobile system, the proprietary driver provides only the ES driver, and if you're on the x86 side, the NVIDIA and AMD proprietary drivers probably only support the desktop OpenGL. Does it make sense?
Yes. So I think there's lots of features and extensions to go implement and test failures to fix, and some of those apply to both. And once we get past kind of the early stages, then it's a matter of priorities of which things we go go fix. And that's mostly user space, which is not the two of us. It's though Tomeu's done more in user space than I have. But Alyssa is doing the majority of that work, and she's probably the critical path now, once again.
So you believe that most of these drivers could support desktop OpenGL, at least to the level that the Linux desktop applications use?
That would be my guess. I'm not really an expert in that area, but I think you kind of get it for free with Mesa.
So it depends on the
Freedreno hardware supports both, and I think the etnev stuff already supports GL. Right?
There's some stuff in BigGL which can be implemented on the higher layers in a Mesa, and there's some stuff which needs specific work on the Gallium drivers. So it depends a lot on which features from BigGL, which are in GLES, does that application use specifically.
Right.
But I think that Mesa kind of helps with that problem with having both GL and GLES, because it provides GL, something like the proprietary drivers weren't doing. So that problem is kind of stopping being a problem with all that.
It's great to see progress on so many different drivers, but is it fair to assume that apart from maybe Freedreno, most of those drivers are still in a catch-up phase and mainly driven by community rather than the companies? And are we seeing any progress in getting companies to also start planning on this as a base for their future generation chips?
Yes, so at Collabora we have customers using the free drivers. And that's quite important, because we cannot help them well if they are using blobs. We cannot just help them. And they are putting those into products, not just Freedreno, but also etnaviv. And for some use
But for
cases,
example, you were mentioning that the support for the IMX8 generation of chip, which is already out there in hardware, still needs to be implemented in the driver. So we're still catching up there.
Totally, because we don't have access to the silicon before it's public, so we cannot start reverse engineering.
And IMX8, I think, only went upstream in the last release or two of the kernel. But there's, like recently, Freedreno 2XX generation hardware support was added, and that's for IMX. Well, it's actually in IMX5 hardware, and that was funded by the company that's interested in needing to support that as well. So.
And from on the ARM side, I mean, the official answer is still we provide the DDK. We've got the proprietary driver, but we're paying keen attention to Panfrost, and we certainly want to collaborate on the kernel. Hope to move that, but we're paying attention.
I talked to a number of companies at Embedded World, because there are hundreds of board vendors, and they all had different answers, but there were generally 3 different answers that I got a lot. And about a third of them, maybe more, said they're only working with the proprietary drivers because they depend on the BSP from the chip vendors, usually free scale in case of the industrial market. But there was almost the same number of companies that said they definitely rely on the open source drivers today, and they can, for their customers, it's already, they absolutely need the open source drivers, because otherwise they cannot make it. And then there was another group where they had tried the open source drivers in the past and they didn't quite get it working, and then they went back to the vendor BSP. And they were willing to try it again, but they had made bad experiences in the past when it wasn't as good as it is now. And there was generally a lot of excitement about Mali getting some support upstream, but it was too early to say anything specific about customers. And
So getting back to grants, so are you seeing any particular criteria that stand in the way of adoption by companies such as ARM, in this case for Mali drivers, for next generation drivers to be based on the new open source drivers exclusively? So is this a matter of performance, equality to the current drivers, or is it driven by feature completeness?
Take that.
To begin, okay, so we have commitments to customers, and there is a whole process and commercial engagement with commercial projects that the DDK is part of that, right? We've got an engineering engagement, and disrupting that can be very bad for our customers, right? So that's one of the reasons why I say we are committed to the DDK, is that we are not going to disrupt the existing engineering processes that are going on. Okay, so that's one side. For
does that include also future generation, or does that include the current other generations?
That includes all the generations, right? Because we've got commercial engagements with SoC vendors and partners at various levels of development, right? We also have a ton of engineering work going on IP that is still going to be several years out before it shows up in silicon, right? So, and that there is, all of the focus is internal on ARM. And we could have a nice debate right now on what is correct, what is the most effective engineering procedure, and the regular open source discussions that we have, and I would agree with you on pretty much all the points. Well, no, I'm just saying that there's the other factor to consider is that we don't want to disrupt the customers, that we want to continue to support the customers in the way that we're supporting them now. So we have to pay attention to that. There are barriers to going open source, and I can't talk about that in a room with a camera that's recording what I'm saying. There is, within the company, there is certainly desire to have an open source solution, and we have to do so in a way that we as a company are comfortable with. And that takes time. So now, when we're talking about Midgard and Bifrost, those are parts that we've already gone through all of our engineering design cycles. It's now in the hands of developers. There's many developers who have access to this. So Panfrost is very interesting. Panfrost, there is the ability to access customers that we can't access with the DDK. Okay. Now that's as much as I'm willing to say in this room. I think my personal opinion is that we really need to embrace the open source drivers, and we need to figure out a way to do that in a way that the business is comfortable with. But doing that takes time, and I feel like I've got a better answer at this Connect than I did at the last Connect, but it's still not a good answer. The only thing I can say is working on it.
I just wanted to add to what Arnd said about the industrial view of it, because what's happening, I think, is that until now, the new features in the GPUs have been driven by pretty much handsets, like wanting like this new shiny feature of GLES or GL or CL or whatever it is, very quickly, not right now, with one finger on the fast forward button. But what's starting to build up now, especially with platforms like Freescale, is a legacy of systems that need to be supported for 20, 30 years, that have graphic displays on them. They are internet connected, they definitely need kernel upgrades, and the vendors, no one mentioned, no one do not really want to support delivering blobs for 20 or 30 years for newer kernels, because that will cost them a lot of money. And I think there is like something about economics of scale to be learned from here, that if you just provide the right data sheets and maybe a little bit of engineering, you can get long-term support for really cheap. That I think is what's going on right now. That's the crucial point.
I'd say it's also support and size-wise of customers, because NXP can't support all those small customers, and they can't get support, so they need the open drivers for that reason.
And NXP, now that they have 64-bit chips out there, are working with us with Vizoso to also have like long-term supported Linux distribution out there, and then there is no way to work with those proprietary blob solutions, so it must be something that can be at least built by a customer against an open kernel and suitable integration with the system provided.
This might be a very short answer, but is there any action on imagination? No.
So I was talking to one vendor about switching to the open source driver, and that's why I mentioned benchmarks, because their BSP team came back straight away and said, oh, minus 50% in the last benchmarks we did. So I think if you're going to try and persuade vendors to switch on these industrial things, then we need a much better argument of, oh, it's not, you know, maybe it's a little bit worse, but it's not, you know, orders of magnitude less performant.
I would disagree with that, because usually what you need for an industrial product is something that is fast enough. You don't care if it's any faster than what you need. And if a specific hardware with that is fast enough with the closed source driver, but the closed source driver doesn't work in your business model, the open source driver is not fast enough. You just go to the next faster product, and that if that works for you, then you take that. And there might be an empty set of available hardware, then you have to come up with a different idea. But if it works, then that's good enough. If you want to ship the product with a 2K video output and you have a chip that does 4K video, but the open source driver is fast enough at 2K, then that's okay.
So I agree with Arne, but to be honest, the last 10% of performance, you basically, because of all of that, you can make progress much faster, you can maintain it better, you can make faster upgrades, but you are forced to make some trade-offs which are different from the trade-offs that the blob vendor can take, and maybe that means that you will be always 10% slower, maybe not, depends a bit. But
so I've been in this industry for 50 years, and I remember when accelerated graphics was simply anti-aliasing, okay? And a lot of embedded systems do not need the fastest graphics in the world or the most complete graphics in the world. They just need enough graphics to be able to handle that and to offload the CPU from having to do that itself. One of the great things about open source, however, is that you typically come out with version 1 of the product, and then over time it gets faster and faster or better and better. It's not always, but a lot of times. And I think that's because the proprietary vendor is not going to go back. After they lose interest in that chip, they're not going to go back and make it any better. But the open source community continues to make things better over time. I have seen that. So I would say, and I don't know if he's here in the room, but Professor Zufo has come here a couple times, and he's had some students working on a GPU made out of an FPGA. Unfortunately, the 2 students who did most of that work have moved on, but he's getting a new crop of students who are coming in to finish off that project. And it might well be that if we find a bunch of stubborn GPU vendors who will not help us, that they will find out that they're going to lose a lot of business to the FPGA vendors.
And I also heard of a RISC-V GPU. Never mind.
Is the camera still rolling?
I saw there is mention of Android support for NEMA, but I'm wondering what's the status, overall status for those open source driver on Android.
So there's quite some work going in the Android platform in Mesa in EGL. Not much is needed in the Gallium drivers themselves, but as Rob was telling me before, when he started testing that, he found issues, especially how buffers are shared, how they are imported in each consumer. And we have seen as well that problem when enabling Android on mainline or on IMX, that because there's a lot of different components and there's styled formats, so every component next in the pipeline has to know exactly what format there was. So quite some work had to be done on modifiers which tell the other the component how it is, and that's not yet wired up in the Android platform in EGL in Mesa. But there's work ongoing.
Yeah, so specifically I think for Drino, Etnev, the Intel driver, AMD, Virgil all work on Android. And yeah, it's usually some buffer tracking that has to be added and various GL extensions and like things like texturing from YUV buffers. It's needed.
Personally, I would like to thank you for the work, because I think that from connect to connect, the need of asking the so-called Mali question became less and less important. It's like a few years ago in Budapest at Connect, all I had to do in Mali's driver session was to go and sit in the front row, and I didn't even had to ask anything. They looked at me and it was like, we know which question you want to ask, right? I don't care about Mali anymore. I don't use any Mali hardware, and people think they do, but I like to track the situation of Mali driver, the open one. It's always good, the status reports give, oh shit, yeah, this one has Mali, fuck. Yeah, so yeah, I have Mali one. Or, yeah, you're right, it's MediaTek 8173, and this one has Power VR, so which means headless. Yeah, but you know, I got it for free. So thanks for work, because it's good to have open driver for a platform which is more or less done when it comes to ARM work.
Yes, I could also echo that, because the question number 3 that he's been asking is always a part of the question number 1 that we had when we started Linaro, which is when can we actually get all the SoCs supported in the mainline kernel with one distro running on all of the hardware. And without a GPU driver, this has never been possible. And there's so many things where the mindset just goes off in the wrong way if you think you can never get to the goal. So now we are at the point where the last big piece of the puzzle is falling in place for having something where the mainline kernel can just work on everything. And that means that we can start, like that we can resume telling people to get all the other stuff in place that has been easier and that they didn't do because it was hopeless to start with. Now it's no longer hopeless. And that solves question number 1.
Well, we're here because of all the work that Alyssa and others have done just in reverse engineering.
I've already got a microphone. So my question is, you said that you were blocked by not having a lot of the information from chips that haven't been released yet, and so therefore you're always behind. Could this be solved by either having somebody pay the vendor to have an engineer, either their engineer or some other engineer under NDA, to work on this driver before the chip gets put out? I mean, I understand NDAs very well, unfortunately, and a lot of times it's the NDA is in place only because the vendor never knows if they're going to actually produce this chip, bring it to market, and therefore be under some type of legal issue that somebody would bring a suit against them for saying that they were going to do that.
So paying the SoC vendor or the GPU vendor?
Either one.
Yeah.
Okay. Pay, actually have a paid position where the engineer will sign an NDA or be under the NDA of the company to create the information that the open source community needs to support that chip better when it actually ships. And even go back with some legacy chips to produce the information that the open source community needs to support the chip better. Would that be a solution? Could that be a solution?
Well,
I think with the SoC vendors, you're going to have problems if they've signed contracts with the GPU vendor that says like no reverse engineering and.
But this isn't reverse engineering.
And they have access to the some of the source for the GPU and as well as RTL, and that could all be.
So the best thing would be to go to the GPU vendor and work this, that they could then license that back out to their SoC vendors as they wished.
I'll let a GPU vendor comment on that.
I think it could work, but in practical terms, what we'll see is what is happening with Intel, for example. Intel has their own graphics team working with Mesa upstream, and they are able to do that by their own. Now we are in a phase where we first need to get people to use what is out there, and once that happens, then the vendor is in a better position to start thinking if their DD key shouldn't be based on Mesa, and if their own engineer shouldn't be working upstream. When that happens, then they can internally develop for the newer one and to be released.
But what if you had a third party who had an interest in seeing this happen?
I think it could work as well, but
hold on.
Let's talk.
Mm-hmm. That's you've got to what will the GPU vendor, are we willing to do that right now? No, that's not the barrier. Does that need to change? I think so, but that's not the what you're describing. That's not the barrier. It's something else.
Okay. But some other GPU vendor might be willing to do that.
And some other GPU vendor may very well.
Okay. I had a conversation with the people from Vivante recently, and it seems to be very similar to the situation that Grant described. So I don't think it's that different. Might be different for Qualcomm. It's certainly different for Broadcom, who ended up doing the same thing as Intel and hiring the open source people and working with them. But I don't think, no idea about Qualcomm, but it seems to be the same thing for Vivante and ARM.
I would think that Qualcomm is more similar to ARM, but Vivante is special because their own binary drivers are not that good. So it's quite easy for us to beat them. They are special in that regard. Qualcomm and ARM put a lot of resources, they help a lot of the big customers, etc., but Vivante cannot do that very well.
But they also don't seem to have any interest in working with anybody at Vivante. So it's unlikely.
Something that happens, and that's related to what I said before, is that each company, the graphics team, works only on their own stuff. They don't see what the others do. But when we work in Mesa, everybody sees what the others do, right? So we have a better idea of who is better, and what state are things, how things can progress and get better. If you are working on your own company, on your own hardware, you don't really know about the others. And everybody thinks is the best, right?
So I think that most of the SOC vendors affected here are still in a learning phase with regards to open source, not specific to the GPU drivers, but most of them actually all do their own like BSP or downstream forks first, and then some of them, not all of them, start upstreaming once the chips are already in the hands of the customers. And thereby they would not have a benefit by investing into the GPUs early because they don't have their own SOC drivers ready in their time. So I think what would need to happen is for them to understand the business benefit of having the code ready in time for when the devices actually ship. And then it would also become a business benefit if then an IP vendor is able to provide open source driver components that the SOC vendors can integrate and then ship at that time. Which then in turn may influence the decision of a SOC vendor which IP to buy.
So, business case talks, right? The most valuable thing that anyone in this room who has influence over a silicon vendor or is a silicon vendor is to, you know, if you're licensing from ARM, tell us. If you're licensing from someone else, tell them that your business requires open source drivers. Describe, you know, if it impacts sales, if it impacts licensing, that the building your products depends on open source drivers, please say so. Please say so strongly. Please say so frequently. We need to hear that. It helps make the argument. I mean, within ARM, there's lots of us within ARM who want to do open source drivers. We want to have an open source solution. We know why it's important. There are barriers that prevent us from doing so right now. It's taking work to break those down. Having that information go through the sales channels helps to work through that.
So at Disconnect, I heard about the program to do software qualification for 96 boards. And in that program, they say, okay, you put out the board, it has to support these pieces of open source, and you have to, in order to continue your certification, you have to continue upgrading that and supporting that and so forth. Okay, so that's the board vendor. But the board vendor uses an SoC.
Yep.
And inside that SoC, there is a GPU. And so if the GPU vendor stops producing their code to support that, then the board vendor can't go forward with new kernels and new distributions. So automatically, you're going to be cutting down. You're going to be saying to people for 96 boards, do you think you can follow this program? Because, you know, within a certain, unless you can guarantee that GPU vendor, who's going to guarantee that SoC vendor, who's going to guarantee that your board can pass those tests, you're not going to be able to belong.
Yes, that is a business case argument that we need to hear, and we need to hear frequently.
I'll send you email tomorrow.
Please do.
Any last comments? All right, well, thank you.
Thanks.